Hello and welcome to this episode of Math with Martinez. We are in our Algebra 2, Unit 3, where we are looking at systems of linear equations and inequalities. And it's inequalities that we're going to be focusing on now as we move to our objectives 2 and 3. Both objectives 2 and 3 are going to be our focus in this video. Formulating and solving systems of two or more linear inequalities, and determining the possible solutions in the solution set of systems of two or more linear inequalities when you have two variables, both the x and the y. So let's go ahead and turn to our notes on solving systems of linear inequalities and look at a few examples together. You'll notice here that if we're going to solve this system, it is going to require us to use some graphing to do so. So whenever you're solving systems of inequalities, we're looking predominantly at our graph, and we're going to find a solution region that'll represent all the possible answers to that system of inequalities. So let's go ahead and begin and follow these steps that we see here. Step number 1 is going to be to write each inequality in slope-intercept form. We're writing each inequality in slope-intercept form. So why don't we go ahead and begin with coming here. We're going to highlight our first inequality, and I want everyone to do this in red or pink, but the first one will be red, and then the second one will be blue. And this is going to help us to distinguish the different regions that are generated. You'll see what I mean in just a minute with that terminology of regions. So red, let's begin with our red inequality. Let's write it in slope-intercept form. Right now, what we have is 3x plus y less than or equal to 4. We need to put this in slope-intercept form. That's like y equals mx plus b. Remember, you might want to even make a note to yourself that slope-intercept form. What does that mean? We want it to look like y equals mx plus b, except that other than an equal sign, you'll have an inequality symbol, but that'll be okay. So all we need to do here for this one is just take that 3x and pass it, to the other side. And to do so, we'll just subtract 3x. So that'll be y less than or equal to a negative 3x. I'm going to put that first because it's like my term, the linear term, and that's usually before your constant term. So now this is ready. And we need to do similarly with our second inequality. We have x plus 3y less than negative 6. Give yourself some space here. This one's going to take a couple more steps. Like we did before, we need to get our linear term, the x term, to the other side. We'll do so by subtracting because it is positive. So it's a negative x minus 6, but that y is still not yet by itself. What do we need to do to get y by itself? We need to divide every single term by 3. So that's going to leave us with a negative 1 over 3x, and then a negative 2, because 6 divided by 3 is 2. Okay, now each of these inequalities is ready to be graphed. We're going to begin with our red inequality. And we're going to graph this inequality. And a reminder to you all, when graphing inequalities, like you did in Algebra 1, you're going to use a dashed line like this. It'll be dashed for when you have a strictly less than or greater than, and you'll make a solid line when it's got the equal to. When you've got this equal to underneath, you'll make a solid line. You'll shade above when your symbols are greater than, and you'll shade below when they are the less than symbols. So let's go ahead and begin graphing here. We always want to begin with our b value, and that is for my red function at 4, for my red inequality at 4. The slope of that inequality, the slope, is negative 3, which means it is a down 3 from there. So I'm going to go down 1, 2, 3. it's not over, there's not like a denominator, so it's an understood 1, which means we're going to go down the 3, 1, 2, 3, over 1, and put our next point there. We can do it again, down 3, over 1. And that's more than enough because we've got rulers and abilities to make nice straight lines. Okay, now is this line going to be solid or dashed? Well, because it's the less than and equal to, the equal to means we'll make it solid. Okay, there we go. Now the last bit here, before we begin graphing our blue function, you got to do all these parts, then shade above or below. Well, look at that inequality. It's y's less than. So we need to shade below where we cross on the y-axis. So here's where we're crossing on the y-axis. So we want to shade all of this that's below it. We want to shade on this section of the line, on this side of the line, which would be below the line, specifically where it's crossing on the y-axis. Then we do similarly for our blue function. Where do we begin to graph for this one? At -2, because our b value is -2. Then we move according to our slope. Our slope is -1/3. So that means go down 1/3. That's all I can go in that direction. So I could also go up 1, left 3. This line, dashed or solid? Dashed or solid, you guys? It's dashed because it doesn't have the little equal to underneath it. Because it's not equal to underneath it, it's going to be a dashed line. So we're going to come in here and make a dashed line, connecting those points. And now time to shade. Look at that inequality symbol. It's y's less than, so we're going to be shading below our line. Everything below that blue line. Okay, now we really have here 4 different regions. If you think about this with me, you've got this region here. Maybe I was going to use Roman numerals, but I'll just call it 1. You've got this region here that's red. You've got this region here that's like both colors, and then you've got a final region that's just blue. Do you guys see those 4 different divisions? The solution region is the region that makes both inequalities true. The solution region is the region that makes both inequalities true. It's going to be the intersection of the 2 solution regions. So the solution region are going to be in region 3 for this example. The solutions are in that 3rd region, and you could pick a point from there and check to make sure that it does make both of those inequalities true. Take, for example, -3, -3. That would be a solution. That's just one of many. And if you go and plug it into the original or into these inequalities, check it out. It would be -3. Is that less than or equal to -3 times -3 plus 4? Well, that means -3 less than or equal to 9. What is 9 plus 4? 9 plus 4 is 13. And -3 is, in fact, less than that. And check it in your second inequality as well. -3 less than or equal to less than -1/3 times -3 minus 2. Well, let's see. Is -3 less than? That's going to be a 3 minus 2. But what is 3 minus 2? 3 minus 2 is just 1. And -3 is less than 1. So that makes both true. So yeah, we can confidently say that the solutions are in region 3, that region where it's both red and blue. So there you guys go. That is solving a system of inequalities and identifying solutions from that solution region. Let's do a couple more here. Start off by labeling your two red and blue. Step number 1, write each inequality in that slope-intercept form. Okay, well, the red one is the only one that needs to be rewritten, so let's go ahead and work with that one here down below. We're going to need to take and subtract the 3x on each side. Negative 3x minus 3. But then the y still isn't yet all by itself, and this is what I wanted to make a note of over here in our margin here. Be sure to flip the direction of your inequality symbol if you multiply or divide by a negative. And right here, I'm going to need to divide by a -1. Every single term is getting divided by that -1, which means then I'll have my y by itself, but I've got to flip the direction of that sign. This is now going to be a positive 3x and a positive 3. Okay, now that inequality is in the form where I can go ahead and graph it. So let's go ahead and do that. We're going to begin at our b value, which is at 3. And then the slope is 3, which would mean I'd need to go up 3 and over 1, but I can't do that here. My window's too small. So I'm going to go down 3 and left 1. Down 3, left 1. Oops. All right, that's looking good. What kind of line do we need to have? Is it going to be solid or dashed? Look back at your notes. Look back at your notes. This is going to need to be a dashed line. I'm going to make it solid and then erase little bits of it here, because I have that capability. There we go. So little dashed line. And then we need to shade. When you shade this, it's red y values greater than. That's how you read this symbol right here. That's greater than. So we need to shade values greater than this line. That's going to mean everything above the line. Splendid. Now, our blue inequality. We're going to begin at what value, y'all? At -1. And then move according to our slope. That's up 3 over 1. Up 3 over 1. This is once again a dashed line because it's strictly less than. So we'll make our dashed line. Just like that. And then we want to shade according to what our blue inequality says. It says y values less than. So I need to shade everything below this line. Below the line's going to be here. Okay. Now this is interesting and different from our last one. That's why I wanted to include this example. We kind of have 3 different regions here. We've got this completely red, this region with no shading at all, and this third region that's only blue. So what's unique about this is there is no overlapping. There's no points that make both inequalities true. The solution is supposed to be the intersection of the 2 regions, like we saw here, what I would call purple, because it was red and blue combined. There's no red and blue overlap here. So what that means is that there are no solutions for this system. No solutions exist. There's nothing that would make both inequalities true. All right, now last but not least, I want us to solve this system. This system actually has 3 equations. So what we're going to do here, we're definitely going to need to start with color coding these. Red, blue, and let's go green. Okay. So let's begin with our red inequality. We need to get it in the form where we can graph it. Okay, so if we're going to try and graph that, I'm definitely going to need to take and pass that term with x to the other side. So then it'd be a negative 4y equals a negative x plus the 12. And then we need to divide everything by that negative 4. When we divide by a negative, remember that means we're going to change the direction of our inequality symbol. Negative divided by negative is going to be positive 1/4 x, and then minus 3. So there's my first inequality. Then my second inequality, that one also needs a bit of reworking. Just taking that x term to the other side. Done so by subtracting it. No problem there with that one. And then the green, I'm going to work over here. All right, we're going to have to take the 2x to the other side. So that's going to be minus 2x and then the minus 4. And again, divide every single term by the negative so that y is isolated. And that's going to give us y. But because we divided by a negative, we have to change the direction of our sign. This is going to be a positive 2x and a positive 4. Now, one at a time, we're going to graph these and shade, and then we'll finally be able to identify solution regions. So let's begin with our red. We're going to begin at negative 3 and then move according to the slope. That's up 1/4 or down 1, left 4. That inequality symbol is a greater than or equal to. Because it's the equal to, it's going to be a nice solid line. And it was, once again, we read that as y greater than. So we're going to be shading everything greater than that line. Everything, above that line. Do so in red. If you're just using pencil for all this, it's going to be really hard to tell the difference in all 3 of your shadings. Okay, now blue. We begin at 2. Oops, I'm so sorry. I need my pen. There we go. And then move according to your slope. That's down 1 because it's negative. Negative 1/1, down 1/1, down 1/1. Okay. It's y values less than and equal to, so we're going to have a solid line. And it's less than or equal to, that's how you read that symbol. So we're going to shade everything below that line. Perfect. I can see the double shading right there. It looks kind of gray, but we still have one more inequality. Let's see where that one's going to put us. Okay, we're going to begin at our b value of 4. Then move according to our slope. Well, I can't go up 2/1, so I'm going to go down 2/1, down 2/1. There we go. It's y's less than and equal to, so solid line because it says equal to. And it's y values less than, so I need to shade below that line. Find your y-intercept, and then shade everything below that y-intercept. Okay, so your solution region is the place where all 3 overlapped with each other. And that, ladies and gentlemen, is going to be right in here. Oops, I just want to write it with a pen. I'm just going to write it in here. any point inside that little triangular area would be a solution, would make all three of those inequalities true. So there you guys go. We have now seen how to solve systems of linear inequalities. We've seen when there are no solutions because there's no overlap. And we've even seen how we can find solutions when there's many inequalities overlapping. If you had any questions, please take a moment and share those now. And until next time, stay fired up.